Thank you very much. Colleagues, welcome to day 2 of our program on ideas that work for industrial development. Let me take this opportunity to highlight that we had our official welcome yesterday from the CEO of the CSIR, Dr. Thulani Dlamini. But once again, on behalf of the CSIR executive, allow me to welcome all of you back, especially those that are coming in and joining us for the first day today. Yesterday, we enjoyed having a conversation in the plenary about the current realities of our economy. We spoke about the challenges and the policy frameworks that are guiding and shaping our economic performance and so on. We also spoke about issues to do with the skills that are required to underpin a performing economy. And we discussed the challenges and opportunities therein. Today, we're going to be changing tack a little bit and talking a little bit more about the technologies that are transforming industrial performance, the technologies that are really here right now, and technologies that are emerging. And to that end, the plenary this morning is entitled Industry 4.0. And we have the honor of having with us today representatives of 2 big multinationals whom we have collaborated with, whom we believe are currently living the realities of these transformative waves of technology in their business on a day-to-day basis. And they are here to share that with us. But the third speech this morning in our plenary will focus on a very interesting dimension of all this, which is a presentation from A.T. Kinney, and they've been working very closely with the future of production in the World Economic Forum. They will be talking about what we anticipate about the future of production. They will be speaking to us about country readiness for these technologies, and they will be speaking to us and reflecting on possible social impacts of these emerging technologies. So on that note, let me not carry on too much and take this opportunity to welcome very warmly our speaker, Ms. Janeen Uzzelll. Let me read a little bit of her biography. It is very long, which says she's a very accomplished woman. So, Janeen Uzzelll is the head of Women in Technology at General Electric. In her role as head of Women in Technology at GE, Janeen has been developing and executing company-wide strategy to accelerate the number of women in technical roles across GE's engineering, digital, manufacturing, and product development functions. Her scope includes identifying game-changing moves that all technical functions can benefit from, aligning metrics to measure progress, and leveraging global best practice. From a technical perspective, Janeen has led a very large portfolio as the Global Director for External Affairs and Technology Programs with GE Global Research, undertaking all operational and business development models associated with their global research. I think I'll read some of that, but I won't read all of it. She also pioneered quite a lot of work, including the 6 billion Rand initiative called Healthy Imagination. And you worked and spearheaded work in the health space and many other of GE's competence areas, in Africa especially, which is why I think we have a special connection with you. And you've also been nominated for so many awards, including the Network Journal's 40 Under 40, including Business Leadership Awards, the 25 most influential Black women in business. I could carry on a lot, including also Believers in Business Ministry Organization. You are a member of that. So a very accomplished woman indeed, talking to us about Industry 4.0 and innovation. Janeen, please, let's give her a hearty warm applause.
Thank
right.
you.
So there's your presentation.
Thank you. It's good to be here. Yes, I am great. Can you all hear me okay? Good morning. My name is Janeen Uzzelll. I'm the person with the long bio, which means that my communications person likes me, and she likes to say nice things about me. That's what that means. And I've done a little bit of work. I've been at GE for 16 years, and I spent almost half of those years based in Africa. I was living in Ghana, and I spent a lot of time Sub-Saharan Africa, leading our rural health strategies, actually building and designing technology and products that we've used in the emerging market. I've also lived and worked in India and spent quite a bit of time in Bangladesh and Indonesia. So I consider myself a global girl, but at the end of the day, I'm an American from New Jersey. And I don't know if any of you even know where that is, and that's fine too. So I'm really excited to have a chance to talk to you all. I'd like to give you just a quick overview about GE and some things that are going on with us as a company. And then I'm going to focus on our work in Africa and share some ideas and some stories that I think will help. So those of you that know about GE, and I have a colleague here that's doing work with CSIR and does quite a bit of work in our energy and our power business. But, oh, that's right, I have a clicker. I forgot about that. Thank you. So we are transitioning, and we're what is considered now we're calling ourselves a digital and infrastructure company. We've shaken off some things. We've picked up some new things. If you've been following us in the news, you know that our former CEO, Jeff Immelt, has just transitioned and left. And John Plenary, who was recently the CEO of our healthcare business, is now the CEO of the corporation. And so we're excited for the plans that John has for us and the strategy that he has for this company. But we're a digital industrial company, and we are really committed to transforming industry by connecting people, data, and machines. And those are the things we want to do. And we're going to stay very focused in doing that, and I'll show you in the GE store how we're transitioning to do that. So this is the GE store. And the reason I want to show you this to you is because as we start to talk a little bit about some of the case studies and the examples that I'm going to give you, I want you to understand that this is how we work internally. We've created this model called the GE store, and you'll see many of our different businesses that are shown in the store there. And the goal is that this is a very unique value that we've created within ourselves. So self-investing, saying everything that we need to find, we're going to create it in our store, and then we're going to transfer that intellect and that technology in and out of each of our businesses. So we just overlap into our businesses, and all of the best practices and the shared knowledge is the way that we grow our company. Now, the central hub of the store is the Global Research Center, similar to what CSIR does here. And I am now one of the scientists and technologists at our research center. I'm a mechanical engineer by training, but more than half of the employees in our company have some sort of technology or engineering degree. So GRC is the central hub of innovation across all of the businesses. So we are seeing, moving, growing, and creating across every one of these companies that you see here. And then I think what's newest about us is that we've just recently sold our energy connections business. Oil and gas has now become Baker Hughes, a GE company. And so we've made some changes with what we're doing with the Baker Hughes business. And as you, if you have followed us, you know that we sold the final portions of GE Capital this year. We started doing that last year. And so the goal is to say, you know, we're not doing finance anymore. We're really honing down on some really big areas. So what do we do in health? What do we do in the things that move, the things that cure, and the things that power? And then how do we connect them all digitally? And my goal today is to share some examples across all of those areas for you. So what I'm going to do is tell you a little bit about what we're doing in Africa. And the best way for me to do that is to let someone else tell the story.
Did you know that GE has been in Sub-Saharan Africa for over 100 years, and our first office was in Johannesburg, South Africa. Today, we have over 2,600 employees in 33 sites across Africa, with our biggest operations in Nigeria, South Africa, Angola, Ghana, Ethiopia, Mozambique, and in Kenya, where our headquarters are located. Our businesses in these regions include power, oil and gas, transport, free access to quality healthcare. These memorandum of understanding involve significant investments in job creation and human capital development. Our corporate social responsibility program, Kujenga, is aimed at investing in communities where we operate by empowering people with valuable skills, equipping communities with new tools and technology, and innovating ideas that are helping to solve Africa's challenges. For more information on GE in Africa, visit us at www.ge.com/Africa.
So that's a little bit about who we are in Africa. Our CEO is Jay Ireland. He's based in Kenya. He's the CEO for GE Africa. And he has been inspirational in helping us to transform the work that we do here on the continent. A little bit about GE in Africa overall. We have been in sub-Saharan Africa for over 100 years. However, it's just recently that we've really started to grow across the regions that you heard mentioned. We have 33 sites now, as you know, offices in Nigeria, South Africa, Angola, Mozambique, Ethiopia, Ghana, where I was based for many years, Senegal, Cameroon, Ivory Coast. You can read those here. Over 3,200 employees with a headquarters in Nairobi, Kenya. And our revenue in US dollars is $3.9 billion in 2016. So we have done exponential growth, and we've done it very, very quickly across the continent. In South Africa, more specifically, over 1,100 employees and several facilities. Our GE healthcare business ships over $2 million worth of parts per year in South Africa. We're investing 700 million rand into skills and subject matter expert development and training here in South Africa. We opened the Africa Innovation Center in Johannesburg last year, had a great opportunity to link what we do in all of our research facilities and to bring that. And for those of you that are partners and spend time with CSIR, you should let us set up a tour for you and come over and visit us at the Research Center and the Innovation Center in Johannesburg. It's a show site. It's meant to share a lot of interactive stories, and you can come there and learn a lot about what we do, but more importantly, what we do in South Africa. Our electrical distribution install base is in 9 power stations, and we've done a ton of work in Transnet. Many of you may know that. I'm going to talk a little bit about that study. So we're really proud of not only what we do in Africa, but I want the group here to know that our commitment to the South African economy and the infrastructure is something that we work, very aggressively towards. So I came in yesterday from London, and I had a chance to be a part of the panel discussion, and we talked with several that I had a chance to meet yesterday about innovation. And so I know a little bit about, I didn't attend a lot of the sessions yesterday, but I was here in the morning. I know you all have been busy. I know you've gone through a lot of things, and hopefully I'm going to be able to add to that. I'll just give you a quick update on Kujenga. Kujenga is our social responsibility for Africa. And the reason I am very proud of this, and I want to put it in every one of the presentations I give, is because as a company, we have a CSR strategy, and it's run through the GE Foundation. And so any work that we do that is external to the company in support of social responsibility is run through the GE Foundation. But when we came into Africa, we really understood the importance of creating something local so that we could support the needs of Africa that were different than the needs that we've seen through the lens of the United States. And so Jay decided to build Kujenga, let it focus specifically in Africa, and to fund it in Africa. So it's the only, this is the only region of the world and the only entity that has a CSR initiative that's outside of the GE Foundation, and that's how important this was to Jay and to our team. So let's talk a little bit about the future of work, and not just from a GE perspective. This is something that we all, I think, should keep our eye on, but I'm just sharing with you a little bit about what Marco Annunziato, who's our chief economist, what he teaches us about the future of work, and then how we should use that future of work to think about how we're designing and building and curing. So I'm hoping that as you all look at this, you'll be able to apply it to your work as well. So when we take a look at the future of work, there's a number of changes that are impacting not only our company, but any of the companies. I think it impacts research entities, it impacts private sector, it impacts academia in all of these different areas. So you've got to identify the balance of trade and where your growth is going to come from, and then be willing to shift in those different areas. So what regions of the globe are showing the state of play and where the greatest growth is going to be? Where you're going to be able to make the greatest impact. What new technologies are arising? This is something we talked about on the panel yesterday with innovation and technology. But what new technologies are going to drive the future of work? For us, we're looking at 3D manufacturing, wearables, robotics. And some of that work we're even doing in partnership with CSIR and working and learning from this group as well. So adopting these new technologies is going to be key to how we work in the future. The physical footprint of the factory floor for those that focus in manufacturing is going to be very important for customers, for engineers, for the entire supply chain. So that's a big part of the future of work. The very definition of the workforce, the human footprint, is also changing. And so that's something that we're definitely taking a look at as a company. How is an organization going to be structured in terms of open sourcing, crowdsourcing? These are things that we've not looked at before as a company. And so we're trying to understand, how do we share that knowledge? How do we create these centers of excellence? How do we determine how we will align with the human footprint that's changing? Another part is the CSR and just globalization and the government piece of this. And how big of a role should an organization change or take on in terms of how we impact policy? Do we want to spend our time driving how policy is changed for our business, or should our resources be put into creating a fluid environment that adapts and changes easily? We're still working through some of that ourselves. And then finally, from a CSR perspective, which we talked a lot about, how we continue to support and train programs, our capital investment in the places where we work is very important. So this is a little bit on the future of work in general. This is a little bit on the future of work as it relates to what GE does. We're focused on 3 innovations that have come to light in our company: the industrial internet, advanced manufacturing, and the global brain. So these are the 3 areas that we're currently looking at for the future of work. Again, the fluidity will cause us to change this at some point. What you'll see here are some of the platforms and the workforce impact that we're having in these areas. So when you look at the industrial internet, machine intelligence, and big data and advanced analytics, we're taking a look at our software platform of Predix and how we can impact in the area of the industrial internet. Machine intelligence is captured and collected in the industrial internet, crunched, analyzed, and used to improve performance in machines. So this platform, again, is going to be leveraged by Predix, and we have a team of engineers that have been building on this system. We've hosted a number of hackathons. We hosted our first Africa-based hackathon in West Africa about a month ago, and had students at various universities working on Predix, proving that the platform can be used and integrated into any one of the industrial environments. So this has been a really good opportunity. Again, advanced manufacturing is another area that we're focused on, and we're using our additive platform to be able to drive that. And then finally, the global brain. And Genius Link and Fuse are some of the products that we're using in that space. So as I start to kind of wind this up, one of the things that we talked about when CSIR asked us to participate was really what stories could we share? What best practices or what experiences can we share with you? Things that we've done in collaboration, things that we've led in that we think can actually help set the stage for innovation, for the work that we're talking about here. And I think this is a great time for us to share this and then to hear back from some of you at some point. We're not taking questions during this talk, but we'll be around today, and I'd love to hear your thoughts. So the first case study that I'm going to share is with one of our customers, a cable customer. And we've tried to highlight so that we can focus on a few different things, and I hope that you can see it. I'm going to look closely at my screen here so that I can read it well. So the challenge that we wanted to meet here with the customer is there was no insight into their real cost and their manual WIP tracking. Now, there are a number of actions that the team started to look at in solutions and outcomes, but we wanted to highlight, one of the larger ones here. So we decided to highlight deploying brilliant manufacturing, and that's one of the areas that we focus on as a company in the future of work. It's one of the things that we brought to the customer and partnered with them on here. And so we really had a chance to take a look at how we optimized our software on their existing equipment on the ground to help improve this process. You'll see the solution architecture that we set up here, but I want to take you to the outcomes, which you can see on the end here, and we've tried to highlight some of the things that we thought were great takeaways. Most importantly, I don't know any manufacturing or customer facility that would turn away from a reduction in waste. So we had an opportunity to do a drastic reduction in waste for this customer, as well as improving their planning and scheduling, which is a part of improving process improvement and, again, a reduction in waste. So we're experiencing this shift kind of in progress. This isn't one of those where when we get to the end, we'll see the result. This is a work in progress. We are literally watching this change every day as we see this software work to improve the area. This makes the customer a lot more competitive because without digitization, there's no line of sight to their costs and to their losses. So we're now shining a light on the areas where they're losing and how they can streamline and improve. Anytime we are able to save a customer money, I think that we're doing a great work. Anytime we're able to improve a process that's going to lean out a process, not lean it out in the sense that we're taking away jobs, leaning it out in terms of efficiencies that we can all work better is a part of what we're trying to do. And so this is one of the projects that we had a chance to work on. Let me share another one. Transnet. I love this. The story of Transnet, because it's an experience that I had during my whole time in Africa. Even though I was in healthcare, we were building this opportunity, and I know just how critical this work is. But the ultimate takeaway here was the throughput target and the work that we did with Transnet on this. I think that one of the greatest stories with Transnet was our commitment to localization. And so we customized our software, and we took it from a North American solution, working in partnership with the technologists and the engineers at Transnet and at GE, and said, what's the solution that's going to work here for South Africa? So we changed the model of the software that we'd been using across the globe so that it would be specific here. And that, to me, is a game changer, being able to take a shift, especially for a big engine like GE. It's not always easy to change, culturally, to change our strategy, but to be able to localize that was really important. We leveraged the local expertise of the Transnet engineers. They were right there with us in partnership for this effective design. And I think the big wow and the big takeaway here is the connection of the teleelectric and the diesel electric. So that's the standout innovation that we're taking away from here. I think it's something that all of our teams should be very, very proud of. And then the outcomes are speaking for themselves. 1.2 million tons, increased throughput, the operation of the longest production train in the world. So how we're going to help Transnet move is something that we're really excited to be a part of. So again, I'm just giving you an overview, but these case studies are super intriguing to me, and I hope they are to you, and I wanted to make sure we talk through them if you have any questions, maybe afterwards we can have a chance to talk about it. So the last one I'm going to share before I wrap up is Kenya. I worked in the healthcare space most of my career and all of my time in Africa. And so this one I know well. Lack of infrastructure, access, shortage of skilled healthcare. I mean, we've experienced all of this across healthcare. The team that I worked with was specifically focused on the miniaturization of products and solar products. So handheld ultrasound and how we use that in community hospitals, in rural community settings was what we were working on. And then how we trained a task-shifted user to be able to identify very, very basic entities in the womb. So we took a very large, what I like to call like a washing machine box of ultrasound, and we transitioned it into a handheld size product that we then were able to solar power it, train a task-shifted user to identify placenta previa, positioning in the womb, the length of pregnancy, just in the cord positioning. So just the very, very basics of science so that at the end we had a healthy mom and a healthy baby. And now what we're doing with Kenya is taking those same, we've created a suite of products, and now we're training the technologists across Kenya, and we'll eventually be able to do this across Africa, but the training center is there on how to be able to deliver the services and the use on these same products. So a very strong collaborative project with the Ministry of Health. Additionally, not only have we focused on how we deliver healthcare to an emerging market, but as a result of the work that the teams have done on this, we've created an entire solutions business out of this. So the Sustainable Health Organization is now based in India, where a lot of the products we're looking at are designed there, and then we're working on how we integrate that here in Africa. And so this is one of the key partnerships that we were able to work on. And again, the training centers come out of it and the educational programs that will align with GE's, with the healthcare businesses, focus on capacity building. So I'm gonna stop here, but I was talking to our economist on kind of the takeaway message, and this is what we came up with. Kind of what I'm calling a call to action. So we often hear it said, I don't know if you all hear this, but we hear it all the time. There's so much innovation and there's so little productivity. People tell us that innovation is powerless, that it can't be measured, and that there's no investment in it. And so our call to action is to really reach beyond the state of innovation being all of these things, to take a look at some of the best practices, continue to identify the gaps, and then if we collaborate and work together, the way that you've seen some of the things we've done well. Now, I showed you 3 case studies that turned out well, because you don't think I'm going to stand up here and tell you all the ones we did wrong. But there are plenty that we didn't nail the first time around. But when we work together in science, when we work together with ministries, when we work together even internally within our GE store, we're willing to change our concept, we're willing to be flexible, we're willing to be agile and to take on new thoughts, then our takeaway is that innovation can be incredibly productive. And so it can be as powerful as ever, and then we need to scale it. So we need to take everything that we've done, everything that I've shared here with you, and we need to find a way to accelerate and do it better. So I want to thank CSIR for having me. Thank you very much for inviting me. I hope that this was informative, and I hope I get a chance to speak with you all as I spend the day here at the event. Thank you very much.
Very good. Thank you very much, Janine, for sharing the GE experience with us. And so now we'll move on to the second talk of our plenary this morning. And we will be having, we'll be listening to Dr. Jean-Marc Nasr. That's how he said I should pronounce his name. So I had quite a bit of fun doing that. So Jean-Marc, I will not repeat your surname now. I would just like to read a little bit about your very illustrious career. So, Jean-Marc is the Managing Director of Airbus Defence and Space and head of France, UK, Middle East, Africa for the Airbus Defence and Space Division. His career has always been, since '86, has been in aerospace, where he has been in charge of developing the image processing business, which he led at the beginning of the '90s. He was named the chairperson and CEO of Flexi Image in Paris in '97, which specialized in image analysis software for intelligence services. And under his leadership, the turnover was really increased fivefold for that particular organization, Flexi Image. Jean-Marc was promoted to president and CEO of Sport Image in 2001, a business which handled the commercial distribution of sport satellite imageries. In 2005, he joined the European Aeronautical Defence and Space Defence and Security as president of Secure Networks, and then as CEO of the Integrated Systems Unit. He became president of Cassidian SAS and head of Cassidian France and Security Solutions, including secure communications and cybersecurity. He graduated from an institution which I believe is in France because it's written in French. So I will not try to pronounce that, but he is very clearly accomplished in defense, space, cybersecurity, and so on. And it is a pleasure to listen to the Airbus perspective of Industry 4.0. Thank you very much.
Yes, that will take you forward and back. Yep. There we go.
Hello, you hear me well? Good morning, everyone. Thank you for your efforts in pronouncing my name. Even myself, sometimes I'm struggling with it. Very good. I'm very proud to be having invited by the CSIR to talk to you today about 4.0 for Airbus Defence and Space and for Airbus at large. I was very inspired yesterday evening with the speech of the Minister Naledi Pandor, an extremely powerful speech about what it happens and how things should apply to South Africa, which I think I would follow 100% what she said, and my talk today is going to be in link with what happened. 4.0 revolution, the fourth revolution, we have already gone through 3 others before, is something, sometime in our company, people are saying, is it an evolution or is it a revolution? And people feel nothing is really changing. We are all there, we talk to each other, we have emails. Nothing is changing, but it is really changing. And so those who think that nothing is changing should remind what happened at the end of just before the second revolution, actually. I want to share with you 2 quotes of Henry Ford and Lord Kelvin, President of the Royal Society at the end of the 19th century, when Henry Ford said, if I had asked the people what they wanted, they would have said faster horses. That was right before the automobile became a reality for us. And then Lord Kelvin said, heavier than air flying machines are impossible. If Lord Kelvin was right, we would not be there today with Airbus, because this is what we do. And I also remember closer to us, I'm born in 1961, and I remember an encyclopedia I had at home at the end of the 60s, which was saying that it would be impossible to make electric watches because it would be impossible to put a battery in a watch, too small. That was in 1969. So statements like that are always proven to be stupid. Sorry for those gentlemen that said that, but it is not, things are always possible and they go faster. Look at what we had in our homes and our pockets at the end of the 80s. We had a phone, big normally. We had an iPod, this Walkman we were saying at this time. We had the books, nice books in leather, replacing what is Google today. PlayStations, kind of YouTube thing with a screen and a heavy screen with electrical appliances behind it. Email, look, we had a pen. And I just can't remember how we were working at this time, but we were actually. And then we had a navigation system in the form of books in our cars. All this now is in one little box in your hand, and you have all this in a 100-gram device in your pocket. And that's a revolution. It's not an evolution. It is a true revolution. In this room today, there are more than 300 smartphones connected to cloud, interconnected. There are at least 10 Wi-Fi networks working at the same time. And that's a real revolution we need to take into account. So it's a change. I look at these two. There are two shoes, two running shoes. The running shoe of the 1980s, nice, and the running shoe of today, which has a sensor into it, connected to your watch, that says that if your shoe is still operating well or if you change it. That watch is connected to the store, and the store will call you the next day, say, sir, your shoe must be replaced. That's a reality. It works today. And that's really scary. I am scared with this, because what does it mean for us? What does it mean for our people? What does it mean for the protection of our private lives? This is a real concern for the long run. So then, digitalization, which is clearly the word which is at the center of the fourth resolution, it's an impact on companies and organizations of the fact that people and things are interconnected anytime, anywhere, for every need. That's digitalization. So as a consequence, a digital company is an integrated it's a company that has integrated digital technologies and evolve as an organization level to address digitalization. So when it comes to Airbus, big, arrogant European company, 160,000 employees in the world, making the best airplanes you can imagine. We are in a duopoly with Boeing. We are very, very stable. And in our company, the managers, me included, are in the 50s, late 50s sometimes. We were born before the third revolution. And I have seen a lot of people in my company saying, this is not for us. We do airplanes. Who cares? Yes, we will use the smartphones, we'll do things, but it's not for us. And we started to be very worried about these statements in the last 5 years ago, saying, look, let's look into this seriously now, because it's not a simple case. And we have seen very big companies just missing the turn and losing ground in a couple of years. Look at Kodak. They missed the digital photo, and they are not there anymore. Look at Nokia. Nokia is still there, but remember what was Nokia in the 90s. Remember, the worldwide leader in cellular phone. And they just didn't see these Apple guys coming around with their first iPhone saying that's going to work. So it can impact very big companies, and we started to realize that if, as a corporation, we don't look into this seriously, we can disappear as well. We don't know what can replace airplanes or helicopters or launchers in the long run yet. But look, if we don't look into this now, and if we don't integrate into our processes, into our way of working, what is digital and how it can help us doing better, we will lose ground. And we decided to take this very seriously in Airbus 10 years ago and started to implement this strongly in the company. With the driving factor is we have to serve our customers the best we can, first thing. Second, we have to protect our customers and our products. And the big issue behind digitalization, the big issue behind this technology is the security of our networks. And again, if there is something that wakes me up at night, is this problem. Because our companies are our societies are so interconnected that if something wrong happens, we will be on our knees, all of us. Companies, organization, anything would not work anymore. And it's too late, there is no way back. We cannot come back to the Stone Age and reuse our old Walkmans and things like that. It will not work. So we need to take this very seriously. It's small, it's behind it, we don't see it, but it is also impacting us. So 3 examples why Airbus can be impacted with digitalization. I'll start with SpaceX. One reason is that the person who invented SpaceX, he comes from this country, Mr. Elon Musk, decided that he will do launchers. And we said in Airbus, okay, let him try. Might be easy. We've been there for 30 years. He is starting. It will take him 50 years because he can do it. But he did it. SpaceX is launching satellites today with a completely different model. They use reusable launchers. The launcher comes back on the launch pad, which we thought would not make sense economically, but it does. And that was a good wake-up call for us. Things can be done by a private investor, because this is a private investor, and not by a government, and change the way we do things. And we have decided, as a consequence, to create Ariane Group, Ariane are for launchers, to integrate all the launching capabilities of Europe into one single company, to reduce the production cycles and deliver the best launchers we can. And we are on our way to have our first launch in 2020 that will be very competitive. That was a good wake-up call from Elon. Thank him here in front of you. it was really good, and we moved it. The second one I want to talk about is OneWeb. And here we are part of this venture. We are at the beginning of OneWeb. What is OneWeb? Up to now, in the last 30 years, telecommunication satellites are big, heavy piece of equipment sent into a geostationary orbit at 36,000 kilometers and connecting people through antennas. These satellites are so big, they are all costing between $200 million to $400 million each, expensive the last 20 years, and they have a lot of technology. We decided to see telecommunication in a different way. Why, if we would replace a heavy, expensive geostationary satellite with a constellation of small satellites at a lower orbit that would give the same service, internet for everyone? And we invented, together with OneWeb, with our US partner, a constellation called OneWeb. We will be launching 900 satellites in a low Earth orbit, covering the entire planet and giving internet service to all. And the difference with our former business is that each satellite is a few kilos, around 100 kilos. They are like a dishwasher in terms of size, and not anymore so big. But for us, as a company, we will have to produce 3 satellites per day, because there are 900 satellites in orbit. We have 2 years to launch the constellation. 3 satellites per day instead of 5 satellites a year. That was the revolution. And you don't produce 3 satellites a day the same way you do 5 satellites a year. So we had to change completely our production mechanism. We went to see our colleagues of Airbus Commercial that are producing Airbuses, airplanes. They do more airplanes than us, than we do satellites. And they taught us how to integrate our final assembly line to produce the satellites. And guess what? We today have 2 final assembly lines, one in Toulouse, one in Florida, where OneWeb is headquartered. And we are starting production. We will be doing that. And each satellite is going to be cheap enough that we can replace them if they fail. So you launch the constellation, and you replace satellites when they're failing one after the other. This is far cheaper than what we did before, but we had to rethink completely the way we do things in our company. And when I was saying at the beginning, evolution against revolution, that was a revolution. You have to explain to the engineers, and I am an engineer, that what he is doing or what she's doing must be changed. And you cannot imagine how a French or a German engineer is convinced that he is the best of the world. They don't want to change. They are resisting to change. And the wake-up call was sometimes very, very tough for us. The last one is more the future. We are talking about, we do flying machines. And the next challenge is to autonomous flying machines to transfer people from one place to another one. Autonomous cars is already a reality today and will be in our streets very soon. We believe that autonomous flying cars will also be a reality, and I am convinced that I will see it before I retire, probably. It will be there. Technically, it is possible today. What is missing is the regulation. Having all those flying machines in the sky at the same time, we need to regulate, because you can imagine that we cannot crash in the sky without consequences. So the regulation has to be done, but it will happen. And we are already investing into this with a concept where you have a car, and the car can stop, and the flying part is coming over, take the car, and transport the car somewhere, another place. This concept has been presented last year, and we are working on it. This will happen as well. And that's a disruption we were expecting. Disruption will also happen, we'll take flying machines as we are taking cars today in the future, and without having to go to an airport, lining queues, making a lot of tests and security checks before we can embark into a plane. That will be easier in the future. So that's a disruption we see at Airbus impacting us. It will impact us further. So we have developed in Airbus, as a consequence, new skills that we didn't have before. And I was talking about cybersecurity. Cyber is clearly at the core of all what we do. There is no way for us to develop a new machine, flying machine, without making sure that it is protected against hacking. Today, in an airplane which flies, there are multiple IP addresses that are in operation. An IP address in operation can be hacked. There is no 100% guarantee that it cannot be hacked. We need to protect. And so we are investing together with our innovation massively in cybersecurity. And the average amount of money that you need to invest to make sure that what you're doing is cyber secure is 15% of your IT investment. So if you invest 100 into IT, just put 15 on top to cyber protect your IT. If you don't do that, you're not protected. And that's a war against an asymmetric threat. The attackers are not isolated. We don't know where they are. You cannot target them, but they are there. And we are all afraid of what we call the digital Pearl Harbor, which is an attack, massive attack somewhere, not predicted, that would put our societies on their knees. If you just take control of the traffic light system of a big city like Johannesburg or Paris, 3 days after, you have riots in the streets because there is nothing to eat. And that's the reality. It's nothing else. And that's what we need to take care of. If you look at the aviation industry, this is not clear from where you are, but 15 years ago in the aviation industry, when you look at the left part of the graph here, we could see glass, leather, stone, ceramics, aluminum, paint, wood. That were the things we were seeing on an air show. On the right, what we see today, Wi-Fi hotspot, shutter sensor, digital radar, mobile phones, etc., etc. We look at an aeronautic environment in a different way. There are still materials behind it. There are still big steel equipment around it. But what counts is not anymore the platform itself, but the way the platform becomes intelligent. And that's where we are working today. So I want to share with you a couple of examples of concrete examples of what we are doing. So you look in that slide here, you see the 3 ways we at Airbus include digitalization. We use digital to improve product or customer experience. That's the first thing. We use digital to improve internal operations, do things better and faster than before, like my colleague of GE that was explaining before. And use digital also to improve organization and culture. Having in the same company teenagers and Y generation and very experienced engineers is a challenge sometimes. They don't speak the same language. They're not born in the same world. And in a company like ours, we make sure that those generations can speak to each other and can learn from each other. So the first one I'm going to show you is this one at the top, optimized aircraft operation with real-time health monitoring. That is the first one that for me was a real wake-up call. I didn't think we would find so much out of it. So let me go through that one. If you take an aircraft you take a flight of an aircraft from parking to pre-flight operation, and taxiing, climbing, cruise, descent, taxiing, post-flight. During all these operations, the aircraft is transmitting data to the ground or storing data inside the aircraft. Terabytes of data. And guess what? In the former time, these data were not exploited. They were there, in the airlines, in our companies, and we are not exploiting them. Not at all. And we decided to look into this in a way, okay, let's see what we can do with all this data. And we started to do that. We set up several airlines to do a pilot project, collecting all data during flight operations from all those airlines into one single set of data into the cloud. So storing airman warning and fault, technical logbooks, operational interruptions, everything that happens in the flight. And there are many, many things that are happening in the flight. Then we developed a completely new smart analytics platform to store and to process this data and see what we can get out of it. So we analyzed data, organized data, modeled data, and did some deep learning based on end-user knowledge. And we found out that in some cases, you can predict the failure of an equipment from its behavior. You can predict it. If you have massive data and process it, you can predict it. And we are now working on how we can improve this and do predictive maintenance to optimize the efficiency of the airplane. You cannot imagine how important it is for an airline to make sure that the aircraft will be ready for departure on time and that the failure that will happen in 2 or 12 hours or 13 hours has been managed before it happened. And that's exactly what it brings to us. So this is an explosion of data. We speak of petabytes of data. It's huge. But there is a lot out of it that we can exploit. That's one example of what we do today. It's a reality. And that's the effect of digitalization. Sorry, I'm going too fast. Last one is about massive intelligence. We work also in defense and security. And we are facing, together with our customers, the explosion of data. When you are a security organization and you have sensors connected, you have image data, you have radar data, you have internet data, you have human intelligence, all this is there, available. But if you don't organize it, if you don't connect it properly, there is no way to extract the right information. So we developed what we call the massive intelligence solution, which is very much like the airline concept. We take all this data, analytics together, we process the data in a way we deliver from the data what is expected from the customers. And then we deliver this as a service. Either you buy the machine and you use it, or you connect to the machine and you use it offline, online, as a service, as streaming. And we are starting to serve our defense and security customers and international organizations with this, and it's extremely powerful tool. It is a very different tool than what they had before, and it's not anymore their problem to say, okay, I want a satellite image, or I want a radar data, or I want to look in the internet. All this is a process. We process everything at the same time, and it's available. We don't need to decide to process. It is processed when we need it. So that's already into operation in our company, and we'll also modify further the way organizations and companies and countries are also managing intelligence. And intelligence is a guarantee of sovereignty. If you master your intelligence in your country, you are a sovereign country. If you don't, you rely on others, and anything can happen. So that were some examples of what Airbus is about in 4.0. Again, back to the beginning, I am truly convinced it is a revolution. Yes, there are risks. Yes, there are jobs will disappear. Some jobs will disappear. In the beginning of the 20th century, we replaced muscles with machines, essentially. Now we can say that we support brains with machines more, because we don't replace brains, not yet. Maybe it will come, but not yet. It's a different revolution, but it will impact us further. Yes, there will be crisis, because some people will lose their job. But I am convinced that the creation of jobs that will come from this is far bigger than what we will destroy. We'll have to pass the gap, and we'll have some difficulties to pass it, but we will create more jobs. And that brings our organizations and our societies to the need to develop more innovation, develop more training, and it starts at the school. It starts when you are 5 years old. It starts at the beginning. And if you do it right, I am convinced we'll be very successful. And I truly think that CSIR are taking those steps today. They are really ahead of the others into this. And this is why we cooperate with them, and we think that relationship will be bringing to them and to us the best we expect for the future. Thank you very much.
Thank you very much, Jean-Marc. And after those two talks that were very focused on some very interesting developments in digitalization and Industry 4.0 applications, we're going to change tack a little bit. There is a talk, our third talk, that was supposed to be delivered as indicated in our programs by Wim Plessier. It will be delivered instead by Mr. Marc Saunders. Mr. Marc Saunders is a homegrown engineer from the University of Cape Town, and he's been working at AT Kinney, and he has experience in South Africa, West Africa, the Middle East, on several strategy and operations-based topics involving manufacturing companies. And so on that note, let's then listen to our last talk of the morning on shaping the future of production, country readiness and social impact. Marc, please.
Good morning, everybody. Thanks for clarifying, because I think if you were religiously reading the program, you'd be misled thinking that I was a partner at AT Kearney. But I am standing in for Wim Plessier. He was unfortunately not able to make it today. I think with the previous speakers, we've heard quite a bit about these emerging technologies and the application of technologies. The question that I'm going to be diving into is, how ready is South Africa to leverage these emerging technologies? What happens if these emerging technologies reach full scale in the next 5 years? Will South Africa be able to leverage these technologies or not? Will we be caught flat-footed, or will we be caught prepared? So I'll go through various sections of this presentation. The technologies that we're looking at, which have been covered by a lot of the speakers, involves artificial intelligence, 3D printing, wearables, robotics, and the Internet of Things. Together, these technologies are going to impact the manufacturing sector. I think with previous digital revolutions, the manufacturing sector wasn't too harmfully affected, but these emerging technologies will directly impact the competitiveness of companies, So it's quite important for manufacturing and production companies to pay a keen interest into these emerging technologies. In previous engagements with some companies, they kind of felt a little bit like they were a little bit immune to some of these technology disruptions that will be taking place. Before I dive into the contents, the project that we are working on is called the Country Readiness Program. We are working on this project together with the World Economic Forum. Under the 4.0 projects that are being run by the World Economic Forum, there are 5 projects. One is around the technology and innovation for the future of production, employment and skills, accelerating sustainable production, as well as the country readiness. Within the country readiness band as well, there are a couple of other projects. South Africa is definitely one of the countries of interest for the World Economic Forum, and we'll go into some of the reasons why. So the objective of this project that we are running is firstly to establish a common framework, a common way of understanding how ready countries are for Industry 4.0. A common language that can be spoken between different companies, especially governments and global leaders, to prepare for Industry 4.0. The second is to analytically assess a country's readiness. We may have certain views as to how prepared countries are, but we have applied a very data-driven approach towards determining whether countries are prepared or whether they're not prepared. The third thing is that we will be identifying policy and action levers as well that will emerge as a result of the analysis as well as discussions that are taking place in various countries around the world. The last thing is, of course, to accelerate engagement. Now that to accelerate engagement amongst governments, amongst companies, and other interested stakeholders. When we talk about the country readiness for the future of production, we're essentially measuring the capability of countries to effectively incorporate emerging technologies into their production processes and value chains. The way we measure this is by looking at, firstly, what are the drivers of production, and secondly, what is the structure of production. The drivers of production are looking at a country's preparedness to capitalize on these emerging technologies across different dimensions. The structure of production is basically the base of production within countries. Of course, the larger and more advanced base that a country does have, the more easily they're able to invest and invest in the take-up of these new technologies. Within the drivers of technology, we look at a couple of sub-elements. We look at technology and innovation. How easy is it to innovate within these countries, and how is that going to change looking into the future? We look at human capital. Of course, people are going to need to pioneer these new technologies within each of these countries and within the companies. We look at global trade and investment, the ability to participate in international trade as well as to attract foreign investment. Countries that are very attractive from a foreign investment point of view can leverage this to invest in these new technologies and their application within the manufacturing sectors. We look at the institutional framework. This is the framework set out by the government, the policies that are in place that assist with the adoption of these emerging technologies. We look at sustainable resources as well as the demand environment. How big is the demand environment for the manufactured goods within these countries? Of course, countries that have a large demand environment, that are major exporters, who have very advanced manufacturing sectors, they're also able to more easily introduce these technologies into their manufacturing processes. When we talk about the structure of production, we not only look at the scale of production, but we also look at the complexity of production. how advanced from a manufacturing point of view is their economy. What is the manufacturing value add as a percentage of gross domestic product? If we take it a step more detailed, we have looked at about 86 metrics, and I won't go into all of them, and not all of them are shown on this slide. But if we look at technology and innovation, like I mentioned, we look at the current technology platform, characterized by the availability and use of ICT, digital security and data privacy, and a range of other metrics that characterize the current technology platform. But then again, how easy or difficult is it to innovate within those countries, and how is that going to change within the next couple of years? The same thing with human capital, looking at the existing labor force as well as the future skills that are produced within these countries. The same thing with global trade and investment, looking at the current trade environment as well as the future investment profile of these countries. The institutional framework, we look at government as well as innovation and quality protection, IP protection being very important as well. Sustainable resources, the current base of resources that are used within these countries, as well as how sustainable these are looking into the future. The domestic market environment, this as well, I think I touched on this previously, as well as the structure of production. Taking all of these data points into consideration and individually weighting them in a certain way that gives us a good picture as to a country's readiness. We then plot these results onto a matrix. So on the y-axis, we're looking at the drivers of production, and on the x-axis, we're looking at the structure of production. There's four quadrants or four groups of countries. The global leaders, which are on the right-hand side, these are countries that have a very strong base to start with. They have a very advanced manufacturing sector, and they're very well positioned for the future. What we mean by positioned for the future is that they are prepared to, they're very well prepared to leverage these emerging technologies. Below them, we have the legacy champions. These are countries that have a very strong manufacturing base, but are somewhat falling behind in terms of the adoption of these emerging technologies. And you notice this quite a bit. If you dive into each of the individual technologies, you'll notice that the major developments in artificial intelligence, in the Internet of Things, in robotics, they're predominantly taking place in North America, in Europe, and then there's little pockets of Asia as well. So some countries are definitely more prepared and are already innovating and driving these technologies. On the top left-hand side, we have the high potential countries. These are countries that have a very small current base. This could either be due to the size of these countries, as well as how advanced they are from a manufacturing value add. But they are, despite this, they are very well positioned for the future. They have set the right institutional frameworks, but they are inhibited by the fact that they are very small economies. Then we have the followers category, which is countries that have a very limited manufacturing base and are also underprepared for Industry 4.0. Before I go into the next slide shows a map of all of the countries and where they fit into this matrix. Any guesses where South Africa would fit into this matrix? Okay. I think I heard some followers. I think if I heard closely, I did hear some global leaders and legacy champions. Okay. Okay. So the answer is South Africa. Based on our preliminary results, South Africa is in the followers category. However, it's if you look at its positioning, South Africa is very positioned to the intersection of all of these different quadrants. So it's quite a unique position in the sense that it's relatively easier for South Africa to flip into one of the other quadrants. So as much as South Africa is categorized as being in the followers category, it's very much at the edge of being in the followers category. The USA, Germany, Switzerland, Singapore, these are regarded as global leaders. Like I mentioned as well, they are not only prepared to integrate these new technologies, but they're also pioneering the development of these technologies. You have some of the countries that have relatively small bases, but do have the right framework to adopt these technologies, and also the right investment climate as well. Countries such as Australia, the United Arab Emirates. If you look at the legacy champions, you have India. I think China also. China is not shown here, but it does fall within this area. And then you have the followers. Unfortunately, if you also look at the colors, you'll see that there's a lot of blue. Blue is Europe, as well as there's a lot of blue. There's a lot of red. Red is more on the right, towards the right bottom hand side, which is sub-Saharan African countries that are mapped, being classified as being followers. What's also very interesting is if you look at this, if you look at the black line, it can be regarded as, let's call it the best fit curve. Countries that are below this line are countries that are underprepared. Countries that are above this line are countries that are, oops, I'm going too fast, are countries that are overprepared. If you also look a little bit deeper into the slide, you'll see that the countries that are rather underprepared are somewhat the countries that have benefited from other areas of competitiveness, such as low wages. The countries that are overprepared are countries that don't have that benefit. Industry 4.0 and the countries that don't have the benefit of low wages and that don't have the benefit of low wages, they are predominantly the countries that are seeking to regain their competitiveness through the adoption of these new technologies. If you have robots installed into your factory, unfortunately, to some extent, it does take the place of some employees. But also the design philosophy of working with robots is not necessarily the way it is today, where robots work completely separate from human beings. Robots work in cages. The design philosophy going forward is that there's going to be a lot of interaction and collaboration with robots. They're becoming safer to interact with. They're becoming more accurate. So that does have elements of a little bit of substitution of people, but also does have elements of upskilling of people. You will need better capabilities to deal with, to handle these robots, to give instructions to these robots. So it's quite an interesting finding that these countries are over-investing because their manufacturing sectors stand to regain competitiveness. But it's also a signal to the countries below this line that their competitiveness looking into the future is under threat. I guess South Africa is in a bit of a limbo situation. It isn't in a very clear position, and some could say that it's waiting to move.
Marc, we are intrigued by that map. It's the J in the corner here. Can you come back to it? Because China is the second largest economy, and we don't see it anywhere in your map. Did you chicken placing them any place, or what is the story there?
The exact position of, okay, so we didn't purposefully hide it, because I know China is obviously a point of interest these days, but it is one of these dots. I can't say it is one of these dots I think China is this dot here, to be honest. And the reasoning for this is, although China has had an increasing base of manufacturing, but if you compare China to, let's say, a country such as Japan, China is not necessarily at the forefront of some of these emerging technologies. If you look at artificial intelligence, robotics, 3D printing, these are mostly being pioneered by the USA, Europe, and then some would even argue that Japan is being more pioneering than China. But I think that is something that is an interesting point, and it is probably going to change. It is probably going to change, but at this point in time, they are somewhat underprepared. So, given that South Africa is classified as being in the followers category, but not a strong follower, let's say, but they are in the followers category. What we look at as measures to improve the readiness of countries to leverage these emerging technologies is rather to focus on existing strengths as opposed to focusing on trying to change and improve on your weaknesses. So South Africa does have a strong manufacturing sector, and and within that sector there are strong subsectors as well. So for countries within the follower sector, it makes more sense to focus on the strengths and to prepare those strengths for the adoption of these emerging technologies. Also, within the followers category, the two logical areas to start that will have the most impact, if you look at these as different drivers, which ones will you start with? Which drivers will you prioritize? Within the followers category, it's recommended to prioritize on human capital, as well as ensuring that the institutional framework will enable the adoption of these technologies. Human capital, of course, is quite important because humans will need to operate these new technologies. If your human capital is not adequately prepared, you will not be able to harness the full benefit of these technologies. Looking a bit more closely at South Africa. So South Africa's, if we look at it in terms of GDP, South Africa's manufacturing sector is about 13%. But Industry 4.0 doesn't only affect the manufacturing sector. It also affects the mining sector, and some could even argue the agriculture sector. So in total, and probably even the construction and to some degree, electricity, gas, and water. So in total, we are looking at a huge portion of GDP. We're looking at 30% of GDP. In some countries, this is less, but in South Africa, it's a huge portion of GDP that will be affected by Industry 4.0. Interestingly as well, I guess the services sector in South Africa has been growing the fastest. Mining, of course, declining, as well as manufacturing growing moderately. So this could be an opportunity to spur growth within these industries. Looking again at the manufacturing sector through a different lens, if we look at the manufacturing sector in terms of the employment in the manufacturing sector, it is the only sector that has had a decline in employment since 2010. Although the mining sector has recently been declining, but it has increased overall since 2010. So also, this does also beg the question that these technologies, there usually is almost the elephant in the room that these technologies are going to result in job losses. But if maybe you look at it from a different lens, what is the alternative? So if South Africa is not prepared for these technologies, other countries are going to take the lead. other countries are going to become more competitive, and this line here will further dip. It's already dipping. Looking at some of the sectors in South Africa, if we take the view of looking at the change in volume of production on the y-axis, so these are sectors that have increased in absolute volume, and then on the x-axis we look at a change in production utilization. So sectors that have increased their absolute production and have increased their production utilization, they're doing really, really good. Sectors that have decreased their absolute production and as well as their utilization, these are the sectors that are really suffering in South Africa. And if you look at these results, I think it is quite obvious, as well as if you look at the news headlines over the past years. The textile sector has been badly impacted. The steel sector has been badly impacted, as well as the furniture and other manufacturing. This is predominantly due to the substitution of imports. It is harder to compete. And maybe a personal example of this is that I recently worked on a project where, for a South African company, we were sourcing steel. And one of the options was to purchase steel locally. The other option was to purchase steel from China, from Japan, from Germany, and we didn't really know the answer. And we had to build some models to determine the answer. We dived into each of the we basically modeled out their production as well as their production costs. Although South Africa, we do have natural benefits such as the low cost of raw materials. If it is for domestic consumption, we are quite far away from the rest of the world, so we also have that additional benefit of not having to pay the import charges because it is being produced domestically. But despite some of these advantages, the picture was still rather bleak for South Africa. Some of the steel plants in other areas of the world, they serve bigger markets. They operate at larger scale. A lot of them are also recently built, so they have better technology. They're more efficient. And on top of that, some of these countries also subsidize heavily their manufacturing sectors. So, if you dive into the cost of importing or producing domestically, it has become quite hard to compete with the international market. Looking a little bit closer into the followers category, and specifically into who South Africa's peers are. South Africa's peers on the edge of the followers category: Indonesia, Turkey, Colombia, Chile. These are the kind of countries that they do have relatively established manufacturing bases. If you look further down, countries such as Ethiopia, Ghana, Cambodia, these are countries where not much manufacturing takes place. One could argue about Nigeria somewhat. So where does this leave us in terms of our preparedness? South Africa is, as I mentioned, in limbo somewhat. Looking a bit closely at the manufacturing sector, there are certain strengths that South Africa's manufacturing sector has. It is well established. There is a well-developed and efficient supporting infrastructure. There are good roads. There are good warehousing facilities, etc. There is a good presence of a large number of multinational companies within South Africa. This also assists with information sharing, as well as proximity to growing African markets. That is also a strength. Some of the weaknesses, we have seen that there is a rising cost of production, relatively low levels of productivity, Some argue that there is a lack of highly skilled labor, as well as there is somewhat of an uncertainty in terms of the government's policy. The threats that we are currently seeing negatively impact South Africa. Competition from some of the low-wage and high-productivity nations. There has been a slow in demand. We do know that there has been some volatility in terms of labor unrest as well as political and currency fluctuations. But on the positive side, there are opportunities. Industry 4.0 definitely is an opportunity for South Africa's manufacturing sector to regain competitiveness, but it is in need of strong direction as well as coordination. South Africa is also quite well positioned to the rest of African markets to actually piggyback on some of their growth as well. As well as the previous graph that I had shown, some subsectors within South Africa are actually performing really, really well. So that's the end of my presentation. Thank you.
Thank you very much to our presenters this morning, colleagues. I think you would agree with me that that was a set of very insightful talks. So I think if you would indulge me, let's give another very warm round of applause to the three presenters. So just by way of announcements, I think we're right on time, and we'll be moving forward to tea. And I think an important thing to note then is your program on page 9 and the subsequent sessions where you will find them. And today you will also note that we do have tours to specific facilities that you can enjoy. So you follow the program and look for the details. For example, the Biomanufacturing Industry Development Center tour, page 34 for details of how you get there. Looking at, the tour to the CSIR National Laser Center, page 36, you will find detailed information. So on that very note, let us take a break for tea and proceed to the various sessions. Thank you very much.